Alright, if we want to prove that two triangles are congruent to one another, that means that all of their angles are congruent, and it means that all of their corresponding sides are congruent. So let's take a look at a proof. And what we want to look at first off is if given C is the midpoint of BE, boy, it's an angry triangle, and angle A is congruent to angle D, and that's all we're given. So let's see if we can draw a picture to represent what's going on. Well, I noticed right away that they both share a common point, C. So that tells me when I draw my picture that C needs to be here. The other thing I know is C is the midpoint of BE. So there's line segment BE. And C has to be halfway through that. And that only leaves two possibilities for my remaining letters. So this goes ABC and then DEC. So actually only one possibility for where each one went. Alright, what does Mr. Triangle have to say about that? Well, how about we always start with our given information. Thank you, Mr. Triangle. So let's write that down first. So the first step of our proof is to write down the given information. So angle A is congruent to angle D. I'm going to indicate that in my picture with an arc. And the second step is our other piece of given information. C is the midpoint of BE. And we wrote given as our justification. And how does that help us? Well, that tells us that BC is congruent to CE. And that's just the definition of a midpoint. It's halfway between, which means that these parts are going to be congruent to each other. Now look at what angles we have formed there, and I'm seeing that this angle right here and this angle right here are vertical, so I'm going to say angle ACB is congruent to angle DCE. And the reason is vertical angles. So ask yourself, do we have enough information to prove it's congruent? And hopefully you said the answer is yes, because of we have angle, angle, side. So that's going to be our fifth step. And your last step should always be what you're trying to prove. So we're trying to prove triangle ABC is congruent to DEC, and that's what I listed in my last step. And the reason is angle, angle, side. Alright, let's do another proof. This one's a little bit different. Whoops, the angry triangle got mad at my picture and made a few adjustments, so sorry about that. Whoa, he just changed the LJK too. And this segment. Wow. Thank you, Mr. Triangle. I think now we're ready to do the problem. Okay, prove triangle LMK is, and that would be LMK is congruent to LJK, given that KL bisects angle MLJ and LJ is congruent to LM. Alright, remember we want to start with our given information. So LJ is congruent to LM, and that is given. Make sure that you justify that. And Mr. Triangle says we need to make a note of that over here. Good idea. So LJ is congruent to LM. And our second step is KL bisects angle MLJ, and that's given. And that's going to lead us for number 3, which is, and that leads us to angle MLK is congruent to angle JLK. So MLK is congruent to JLK, and that's because of the definition of an angle bisector. Angle bisector just means it creates two equal angles. That line segment cuts that big angle into two congruent angles. So I'm going to show that with a couple of arcs. So an arc there and an arc there. And now you can see, if we're trying to figure out how to prove this, we have side, angle, we could do side. Let's see if, can we do that? Yeah, we can definitely do that. Do you know why? Oh, Mr. Triangle knows. Well, let's ask him. Oh, he says LK equals LK because of the reflexive property of congruence. And all that reflexive property means that the angle is going to be equal to itself, which you think would kind of go without saying, but we do have a property for that. Alright, so now we do have side, angle, side. So side, angle, side. So we just proved it, and that's going to be our last and final step. So the fifth step, I'm going to put that over here because I ran out of room. And there you have it. Triangle LMK is congruent to triangle LJK due to side, angle, side. Remember, your last step is always going to be whatever your original proof is. And we always have to justify it. Alright, great job. Let's try one on our own. Alright, let's go ahead and try this one on your own. So prove triangle VWX is congruent to triangle YZX, given that X is the midpoint of VY and ZW. Alright, I'm going to pause this. I want you guys to go ahead and set it up and prove that the two triangles are congruent. Alright, let's check your work. Step 1 is X is the midpoint of VY and ZW. That's given. So that proves that ZX and XW are going to be congruent. That's the definition of a midpoint, which means it cuts it into two equal halves. So I'm going to go ahead and put a hash mark there and a hash mark there. And then for step 3, Vx is congruent to xy. So that's definition of midpoint again. Still going from our given information. So I'm going to put two hash marks there and two hash marks there to indicate that. And then you see the angles that are between them are going to be vertical angles. So angle VXW and angle YXZ are congruent, and that's because of the vertical angles theorem. So we're going to go ahead and put an arc right there to indicate that. So we have side, angle, side, and side, angle, side. So we proved what we set out to prove, which was our top statement. Triangle VWX is congruent to triangle YZX, and that is because of side, angle, side. Hopefully you got that right. If not, let's replay it and make sure you get it a second time. And there you have it. You have found your proof.